particle is projected at 50 meters per second at an angle of 60 degrees to the horizontal. It lands sometime later on horizontal ground. Taking g as 9.81 meters per second squared, find the maximum height reached, the time of flight, and the horizontal range. So let's just get a picture. So we know that it's projected like so, at 50, 60 degrees, and then it's going to go through a parabolic path like this and land over here. Now, the components of the velocity, so this one is the adjacent, so we're going to have 50 cos 60 in this direction, and up here it will be 50 sine 60. So looking first of all at part A, we want the maximum height reached. Now when it reaches the maximum height, the vertical component of velocity will be 0. And if we think about the vertical velocity, Vy, that is going to be the initial velocity, which is 50 sine 60, take away 9.81 t. I'm just using there v equals u plus at, and of course, although I should have put it on the diagram, I didn't. The acceleration due to gravity is 9.81, and since I took this as being positive in the formula, this is acting downwards, so it has to be negative in the formula. So we want Vy equals 0, so that's going to give me that t is equal to 50 sine 60 divided by 9.81. So 50 times sine 60 over 9.81 gives me 4.41 seconds. Correct to 2dp. Now for the vertical height, I'm going to use that y is equal to, well, let's actually just state the formula first. So I'm going to use s equals ut plus a half at squared. So that would give me that y is equal to 50 sine 60 degrees t, that's the ut, plus a half of negative 9.81 t squared. And we want that when t is 4.41. So it's going to be 50 sine 60 times 4.41 plus a half times negative 9.81 times 4.41 squared. I've written 4.41, but obviously in the calculation I'll use the last answer on the calculator display. So I'm going to have 50 times sine 60 times my last answer, take away 0.5 times 9.81 times my last answer squared, and that gives me 95.6 meters to 1 decimal place. Okay, so proceed to part B. We want the time of flight. So that's when the particle lands over here on horizontal ground. Now we know, we already discussed this in part A, that y is going to be 50 sine 60 degrees t. Take away a half of 9.81 times t squared. And when we land over here, y is equal to 0. So if we factor out a t, we've got 50 sine 60 degrees, take away a half of 9.81 t, that's going to be equal to 0. Now clearly this t could be 0, but that's when we're at the start. So the t that we're interested in is what comes out of the bracket here. So we're going to have that t equals 50 sine 60 divided by a half of 9.81, and we can calculate that. So we've got 50 times sine 60 divided by 0.5 times 9.81. That gives me 8.83 seconds. Correct to 2dp. And of course that was the answer to part B. Now part C actually follows on from that, because what we're after now is the distance travelled until it hits the ground. Now clearly the only acceleration is the vertical acceleration. So if we think of the horizontal displacement as x, that's just going to be x equals ut, with of course the u being this component. So x is going to be 50 cos 60 degrees multiplied by 8.83. So what I'm going to do is 50 times the cosine of 60, and multiply that by my last answer, and I'm going to get 220.7 meters.